So very good morning guys and welcome back to my solution series. My name is Akrati and today we are going to solve one question of stack. So this is the question number 155 main stack. Okay. So what we have to do, we have to design a stack that support push, pop, top and retrieving the minimum element in a constant time. Okay. So basically we have to implement a stack which will be performing these many operations, which is push, pop, top and get minimum. Okay. So in push we simply have to push an element into our stack. In pop we have to pop element from the top of the stack. In top we have to return the topmost element which is there in our stack. And get minimum, so from get minimum function we simply have to return the minimum element which is there in our stack. Okay. So we have to do all these functionality in just a constant time. So we cannot run a loop or something because in this it is going to take a big of and time complexity. So we are not we cannot do this. We have to do all these operations in constant time. So for a stack, what we can do, like I will the simplest approach what we can approach, but what we can think is like I will simply declare a stack like this. Um, like say I have declared the stack as. Okay. Now in case of pushing the element, we simply know the function as dot push value. Okay, this is the simple way what we can do here. Okay. In pop, we can simply do hash dot pop element. In top we can return as the top and so on. I can perform these three operations in big of time using my simple stack. Okay, but what is the problem here? We cannot perform the get minimum function in constant time using this approach, because if we want to get the minimum element in our stack, then we have to traverse the entire stack. So this is not going to happen in constant time. We cannot traverse a stack in constant time because we have to go through each and element one by one. I have to store that particular element in something, and then I have to pop the topmost element, then I will see the next element, and this way traversing the stack will not take the constant time. So this is not the approach we are going to follow. What we are going to do, let me delete this first. So simply what I'm going to do, I'm just creating a stack which is not containing a simple integer. It is going to contain a pair of integers. Okay. So in my stack, I'm going to store a pair, the pair which is containing two integers, and one integer is the value of the element which we are going to push in my stack, and the second element of the pair is going to contain the minimum element of my stack. Okay. So this way I will keep tracking of the minimum element of my stack, and when I have to return the minimum from the get minimum function, I will just simply do this. Okay. So let me declare an stack which will be containing a pair of integer. Okay. So this way. Okay. Okay. So this way I'm going to declare my stack which is containing a pair of integers. Now what I have to do in push operation, what I have to do, if we are pushing my element for the first time, or simply you can say if the current status of my stack is empty, like as dot empty is true, then what I have to do, I will simply push my element, like I will first of all create a pair and command, and let's call it p. Okay, so first of all I will create a pair of integer. Now I will check if my stack is empty. Then what I'm going to do, I'm going to store my value in both the integer of the pair, like uh, p dot first equal to value and p dot second is also equal to value. And lastly, what I'm going to do, I'm going to push my pair in my stack. So as dot push. Okay, because initially we don't have any element, so the minimum element will also be the element which we are going to push. So I have, stored the value of the first element in minimum, in place of minimum element as well. Now, in case of pop function, what I'm going to do, I have to check if my stack is empty or not. Because if my stack is empty, then simply I'm going to return. Like if we don't have any element, then how will we push? Otherwise I'm going to pop the element. Okay, in case of topmost element, simply I'm going to return uh, s dot top dot first. Here first indicate the value of the element and the second indicate the minimum value of the stack. Okay, so in case of minimum, I'm going to return as dot top dot second, because we know in the second place of the pair we were storing the minimum element of the stack. Okay. Oof, one thing is left here. In the push function, we forgot something, the else statement. So in else statement, what I'm going to do, if my if the element which I'm going to push is not the first element, so I have to check if the minimum value which is already stored in the topmost element, in the second place of the pair, which is there in the topmost, which is there at the top of the stack. So let me just check if. So first of all, what I'm going to do, I'm going to push the value which I'm going to store in my stack as a first place of the pair. Now again, I will push p dot second will be the minimum of the value which I'm going to store, or at the top not second. Okay, and then I have to push my pair in my stack. So this was the entire solution. Let me just run it first. Okay, so it is accepted, and as soon as I will submit it, you can see all the test cases have passed through. So let me again explain you the entire solution first, like what we were doing. Actually, in this is a stack of type pair. Like in simple stack, what we do, we simply store integers. But here we are storing a pair of integer. Okay, so in the first position of the pair, we are storing the actual value of the element which we have to store in our stack, and in the second position of the pair, we are just keep tracking of the minimum element of my stack. Okay, so when I have to push an element, what I will simply do, I will simply make a pair of two integers and let's call it p. Okay, now I will check if my stack is empty. So if my stack is empty, then this means that I'm going to store the first element of the stack. So if I'm storing the first element, then this will also be the minimum element so far. Okay, so I'm storing the value in the first position of the pair, and I'm storing that value in the second position of the pair as a minimum element also, because this is the first element, so this will be the minimum element of the stack. And then I'm going to push my pair into my stack. Otherwise, in the else statement, what I'm checking, I'm just saying that if the element which I'm going to push is not the first element of the stack, then here I need to check if it is the minimum element of the stack so far or not. So in the first position of the pair, I'm simply going to store my value which I have to push, and in the second position of the pair where I was keep tracking of the minimum element of the stack, I will just check if it is the minimum element of the stack so far or not, by the function which is minimum, which compare the two values, and here we are comparing the value which we are going to push, and this is the minimum element of the stack so far, which is there at the top position of the stack. Okay, and in the second position of my pair, and then after this I will just simply push my particular pair in my stack. Now here in the case of pop function, we are simply removing one element from the topmost position of the stack. So I have to check if my stack is empty or not, because if my stack is empty, then we cannot pop anything or we cannot remove anything. So simply I will just return from here, and otherwise I will pop the topmost element of the stack. And in the function top, I'm simply returning the topmost element of the stack, or we can say the first position element of the pair which is at the top of the stack, because at the first position only we are storing the actual element value, and in the second position we will just keep tracking of the minimum element. And in minimum function, we are just returning the second position of value of the pair which is at the top of the stack. Okay, because in the second position we were just keep tracking of the minimum elements, so from there only we are returning the minimum element. So it was the complete explanation of the question. So if you have any doubt or query regarding this question, you can just ask me in comment box. Thank you so much.